This is NECO Maths 2023 question 1, and the question reads P varies directly as the square of Q and inversely as the cube of Z when P equals to 5, Q equals to 3, Z equals to 1. And the two questions asked here is to find Roman 1, the relationship between P, Q, and Z, and Roman 2, you have to find the Z when P is the 3 and Q equals to 5. So solution to this very problem, what you do first is to convert this statement from English into mathematical symbol. If I go back to the question, it says P varies directly as the square of Q, and the same quantity P varies inversely as the cube of Z. So it's this statement that you now change first into mathematical symbol. And to do that, you now write P with the sign of the proportion, and you now write Q square because P varies directly as the square of Q, and you now write Z cubed down because it is inverse proportion with the cube of Z. So this is what you now write first. So next you now remove this sign of proportion and introduce the equality sign with the constant of the proportion. If that is now done, you now have P equals to K, where K is the constant of the proportion multiplied by Q square over Z cubed. Then you now use the values that they are given for P as 5, Q as 3, Z as 1. This will enable you to find this constant of the proportion. So that is what you do next. So when you substitute P by 5, Z by 1, and the Q by 3, you now have something like this 5 equals to K multiplied by 3 raised to the power of 2 divided by 1 raised to the power of 3. It is Q that now replaced by 3, and this Z replaced by 1. So 3 raised to 2 gives you 9, and 9 divided by 1 raised to 3, which is simply 1. So 9 divided by 1 is 9 times this K gives you 9K. So you now have 5 equals to 9K. Dividing both sides by the coefficient of K gives you K as 5 over 9. So having obtained your K, you now go back to this very formula and replace the data K by 5 over 9. That will now give you answer to Roman 1. That is the actual relationship between P, Q, and Z. So let's do that. So the relationship between P, Q, and Z, simply replace the K by 5 over 9 in this very formula. So you now have P equals to 5 over 9 multiplied by Q squared over Z cube. And this multiplication done correctly, that is 5 times Q squared gives you 5Q squared, 9 times Z cube gives you 9Z cube. So the actual relationship will now be P equals to 5Q squared divided by 9Z cubed. This is the answer to Roman 1 question. So now move ahead and answer Roman 2. To answer Roman 2, we make use of the relationship because we are asked to find the Z when P is the 3, Q is 5. So what we now do, you now substitute that P and the Q by the values given in order to find the Z in this very formula. So substituting P by 3, Q by 5, and the Z is what we are interested in finding. That gives you 3 equals to 5 times 5 square. This 5 with the power 2 is the replacement of this Q, and is Z that we wanted to find, and I have replaced this P by the number 3 here. So what we now do, we cross multiply. When you cross multiply, that is 5 times 5 square times 1 here, and this 3 times 9 times Z cube. So 3 times 9 gives you 27 times Z cube. That gives you 27 multiplied by Z cube by the left hand side. While 5 times 5 square times the one below this 3 gives you 5 times 5 square. We're interested in finding Z, so we try as much as possible to make this Z subject of the formula. In an attempt to do that, we divide both sides by 27. That gives you Z cubed equals to 5 times 5 square divided by 27. What you do next is to take the cube root of both sides to find the Z. So taking cube root of Z cubed and cube root of this right hand side, you now have Z equals to cube root of 5 raised to 3 divided by 3 raised to 3. This 5 raised to 3 is a result of multiplying 5 by 5 square. 5 times 5 square gives you 5 raised to 3. And the 27, when changed to index form, gives you this 3 raised to 3. So having these two numbers have power 3 each, you can factor the power 3 outside the bracket. And when that is now done, the power 3 outside the bracket can cancel this cube root. So there in the area, you now have z equals to 5 over 3. And this one changed to make the fraction gives you one whole number, 2 over 3. This is the answer to this Roman 2. That is, this is the value of z when p is the 3, q is 5. So let me share with you how this question is marked according to the official NECO marking scheme. So the very first mark, if I am to mark this Roman 1, the very first mark is the bonus 1 mark. And you have this bonus 1 mark when you now write this relationship with the key there introduced instead the side of the proportion. So you have this bonus 1 mark when you write P equals to K times Q squared over Z cubed. The next mark is attempting to find the value of K when you substituted the value. So given P as 5, Q as 3, Z as 1, in attempting to find this K, you have this method 1 mark. When you have the value of K as 5 over 9, exactly, it gives you this accuracy 1 mark. The next mark is finding the relationship by substituting this K in here to get a P equals to 5Q square all over 9Z cube. If you have this exactly, you have this accuracy 1 mark. So this Roman 1 question has a total of 4 marks. Let me move to Roman 2 question. See, it is marking scheme also. The very first mark in this Roman 2 is the method 1 mark, and you have this method 1 mark when you substitute P by 3, Q by 5 in attempting to get the Z in the formula. This gives you method 1 mark. And the next mark is another method 1 mark in attempt to make this Z subject of the formula. You cross multiply and divide both sides by 27. You have this method 1 mark. Trying to simplify this, still in attempt to get to your Z. Taking cube root of both sides, you have this method 1 mark. And when you have the value of Z exactly as one whole number 2 over 3, that gives you another accuracy 1 mark. So in total also this question has 4 good marks.